Hello, this is Mr. Far Out Roche and his accomplice Wilson, and today we're going to be looking at Relations and Functions Part 6, more specifically evaluating or simplifying function notation. And in this particular series, this particular video, I'll be talking about solving when given a value for the independent variable, in other words an input, as well as solving when given a value for the dependent variable, or the output. So I'm going to put Wilson down over here and we'll get started. Okay, first of all, we're going to be looking at if I'm given an input. What does that look like? Well, here's equation and function notation. Okay, a function f is defined by this particular relation. So here we go. F of x equals 10x plus 2. Remember, for all intents and purposes, it's like y equals 10x plus 2. The difference is we replaced the output with f of x instead of with y. Okay, so here we go. Evaluate or simplify. What is f of 5? Remember, we call this f of x, not f times x. So what is f of 5? In other words, the input value is 5. We put 5 into the function machine. What's going to come out? So I rewrite this just like this. That's my original function. Okay. Now, f of 5 means that the x is going to be replaced with 5. So f of 5 equals 10 times 5 plus 2. So f of 5 is equal to 10 times 5 is 50 plus 2 is 52. Okay? That's it. What if f was negative 4? F of negative 4, the input is negative 4, so is that input. So f of negative 4, 10 times negative 4 is negative 40 plus 2 is negative 38. Done. Okay, so here I said evaluating. So here I evaluated because the answer is actually a numerical answer. If it's not going to be a numerical answer, I'll likely ask you to simplify. So here it says find f of 2a. We're going to simplify as much as we can. So the input is not a number, it's an expression, 2a. It's a monomial. So in this case, f of 2a equals 10 times that same input, 2a plus 2. So f of 2a equals 10 times 2a is 20a plus 2. And of course those are unlike terms, so that's as far as I can go. Done. Oh, sometimes we might even have a binomial we're going to substitute in as the input. So let's do that. F of a plus 5 equals 10 times a plus 5 plus 2. Okay, now I can simplify. We are simplifying. So we can expand these brackets by distribution. So I have f of a plus 5 equals 10a plus 50 plus 2. And of course I can simplify this. So f of a plus 5 equals 10a plus 52. The input is a plus 5. The output, or the value of this total function, is 10a plus 52. Okay. Those are examples of a linear function. This is a quadratic function. You're not doing quadratics until grade 11, but you still might be faced with doing some evaluations with quadratics, even though we won't be graphing them. Okay, so this time we're going to call it, instead of f of x, g of x. And we can call it anything. It's just a way of differentiating between one function and another. G of 10 just means the input is going to be 10. Okay? So, g of 10, g of 10 equals 2 times 10 squared plus 4 times 10. Notice the x's are all replaced with an input value of 10. So g of 10 equals 2 times 10 squared, that's 2 times 100 is 200, plus 4 times 10 is 40. So g of 10 equals 240. So the input was 10, the output is 240. But if we have a binomial to import, or to input, g of x plus 3 equals 2 times x plus 3 squared plus 4 times x plus 3. Okay. First we have to do our exponent before we do our multiplications. And I'm going to use the skills I learned in my polynomials unit here. So g of x plus 3 equals 2 times, I'm going to square this binomial, x squared. The middle term will be x times 3 is 3x doubled is positive 6x. And 3 squared is plus 9. Plus 4 times x plus 3 still. Okay, now I can do my distributions to get rid of these brackets. So g of x plus 3 equals 2x squared, that's this one, plus 12x's plus 18 plus 4x's plus 12. And of course I'll always simplify if I can by collecting my like terms. So g of x plus 3 equals 2x squareds, 12x's and 4x's plus 16x's, and 18 and 12 is positive 30. That's it. My input was x plus 3, my output was that trinomial. Okay, this time, part 2, is what if we're given the output? Okay, this is like if I was given the y value, I had to solve for x algebraically. But this time we're going to give you a value for the output. Instead of calling it y, we're going to call it f of x. So here's a function. If f of x is 2x plus 5, find the value of x if f of x is negative 9. Notice it does not say f of negative 9. It says f of x is negative 9. In other words, the output is negative 9. The output. Okay, it's like the y value. This part is the negative 9. So f of x equals 2x plus 5. I'm going to replace this part with negative 9. Negative 9 equals 2x plus 5. Sorry, that's a bad 5. Okay, now I'm going to shift my terms. I can bring this one over as negative 5 or subtract 5 from each side. So that would be negative 9 and negative 5 is negative 14. And now divide each side by 2 to get rid of this 2. So my x equals negative 7. In other words, if out of the function machine came negative 9, what went in? Negative 7 went in. Negative 7 went in, out came negative 9. Could we check it? Sure. Put negative 7 in here and see what the output should be. 2 times negative 7 is negative 14, plus 5, negative 9. It works. Okay, here's a pretty crazy one, especially for you guys who are thinking about going into pre-calc next year. Just lost my little cube here. Okay. Again, we've got all the math we need for this. This is going to involve our skills that we learned in the radicals unit. So let's try and do this one. It says that this function, the output is 59. So I'm going to replace this part with 59 equals, and this part here is the x. So I'm going to say this part, which is a to the 1/2, is my x value raised to the power of 3 minus 5. That looks pretty intense, but it's not so bad. Okay. Remember, when we're raising a power to an exponent, we multiply the exponents. So it's 59 equals a to the 1/2 times 3 is 3/2 minus 5. Okay. I'm going to get this over to this side. So negative 5 comes over as plus 5, so this would be 64 equals a to the 3/2. Now remember, to the 3/2, the denominator is the index of the radical. The numerator is still an exponent. So it changes to the square root of a cubed. There, that and that are exactly the same thing. Okay, now how would I get rid of this cube? Well, I could cube root both sides. Take a different color for a second. Cube root this side and cube root this side. This cube root and this cube will cancel, so I'm left with root a equals, the cube root of 64 is 4. Okay, now I can get rid of the square root by squaring both sides. This cancels, so I have a, that's an a, not an I, equals 4 squared is 16. Wow, It's not so bad. Okay, here's a final example of something you might end up with. Here's two different functions. One's called g of x and one's called d of x. And just random letters, okay? And in this case, g of x is defined as this relation, x squared minus 7x, and d of x, 4x plus 20. And we want to find out what g of 5 minus d of negative 3 is. Okay, so I'm going to split this up a little bit and do my g of 5 over here and my d of negative 3 over here. So g of 5, okay, replace that x with 5 equals 5 squared minus 7 times 5. Okay, so my input for my g function, okay, it was 5, so I inputted the 5 in here and here. So g of 5 equals 25 minus 35. So g of 5 equals negative 10. Okay, so that is the value of the function g of 5. It's negative 10. Now let's go over here. D of x, well, the x is going to be replaced with negative 3. So d of negative 3 equals 4 times negative 3 plus 20. Okay, I replace this x and this x with negative 3. So d of negative 3 equals 4 times negative 3 is negative 12 plus 20. So d of negative 3 is negative 12 plus 20 is 8. Okay, so now getting back to this, g of 5 minus d of negative 3, well, I know that g of 5 is equal to negative 10 minus d of negative 3, it's right here, d of negative 3 is equal to 8. So negative 10 minus 8 is negative 18. That is the value of g of 5 minus d of negative 3. Done. Okay, I don't think you'll find anything much more difficult than that, if at all. So as usual, if you're working through your workbook and you find that you have some problems or something that's different and you can't figure it out, that's when you ask. Okay, so bye for now. See you next time.